Hello kids at home. We are on this page in the notes today, and today being Wednesday the 14th. We are practicing 3 past AP questions involving the same integration technique. And I told them if you recognize the technique, you should actually be able to crank these out without showing a whole lot of work. The first one, you'll probably need to show something just because it's a definite integral, so you do need to do some calculation. But the other two, and you can see I've taken them off past tests. This was number 32 on a test. This was number 7, and again another 32. So it means actually this one was calculator 32 would have been calculator active, but it wouldn't be helpful. Anyway, go ahead and do those 3. I'm going to pause this while they're finishing, and then we'll talk about them, and then we're learning something new today. And let's take a look at the 2 that don't require any work first of all. If you recognize this one right here, this number 32, maybe even bring the 5 out front to get it out of the integrand to sort of make it stand out more. That's actually a bare naked arctan. What do I mean by that? What's A? 1. U is X. du is dx, like it's as good as arctan gets. So that's 5 arctan x plus c. That's pretty easy, right? Notice the distractors though. This right here, letter E, is the kid who thinks anytime there's a denominator, it's ln. Do you think that happens quite a bit? It actually does. It's only ln if this had been a 5x on the top. I would have gone natural log, and you're nodding. So that's good. I don't even know what some of these other... Oh, this is the kid who says an upside down heart can be broken apart. That's pretty common actually. And called it 5 and integrated it and got a 5x. Do you see what this distractor is? So there's a panel of people on the testing committee that their job is to figure out what will kids do wrong, and then those become the other possibilities. So everything up here is some human being doing it purposely incorrectly. So the best thing is when you don't find your answer, because then you're like, I know I did something wrong. So be very meticulous. Don't just think because you found your answer, you're always right. Let's go look at number 7. This one is also pretty in my face compared to what I had you practice on, right? Because the u is x, the most common mistake is when the u is like 2x or 3x, and kids forget a fraction correction, and that's not even on here. So this is arcsine. Remember, it's antiderivative. And just to review, it's arcsine, because remember we talked about that one being the algebra with the root and the subtraction, and it doesn't have a 1 over a in front, so no 1/5. Somebody anticipated that would happen, right? It's just arcsine u over a. Who u? X. Excellent. And a is 5. It's this one. Arcsine x fifths plus c. How'd we do? Those two should be right. So on the top one, again, if you go u sub, you're going to get it wrong because the derivative of 4 minus x squared is negative 2x, and I can't correct the x. So then that should trigger you as, hey, this looks a little inverse tree with this root and the subtraction. This is arcsine. So I'm going to write arcsine, okay? Be careful. It's not arcsine x, it's arcsine x over what? 2. Arcsine u over a. And we're doing it from 0 to root 3. So this one, you just have to know arcsine of root 3 halves. Do you remember enough about inverse trig to know what that's asking you? Do you know, Bodhi? Like, what does this mean when it's a sine inverse or arcsine? You don't take the sine of an angle, right? Your answer is an angle, right? Whose sine is root 3 halves. So you have to know your unit circle sort of backwards. Somewhere in the first quadrant, I know it's not at pi fourths, there's an angle that has a sine of root 3 over 2. There are only 2 guesses, to be honest, right? It's either pi 6 or pi thirds. Which one do you think it is? Let's go take a look. I always start with the 1/2 here. I don't know how you guys memorize your unit circle, but probably the same way I do. So I don't, you know. So this guy reverses on. All right. So what's arcsine? Root 3 over 2. Pi thirds, right? I think that's what you guys did. But I'm just talking it through slow because we have time in here. Arcsine 0. 0. So I don't need to write that down. Pi thirds is the answer. Did you guys have that one right too, all three of them? Yeah. All right, awesome. This group's amazing. Now we're going to integrate by parts. And this class, those of you at home, I was asking them when I turned my mic off, if they remember doing this after the AP exam, because honestly, I couldn't remember if I did it. It's always something I do. Always something I do. But I wasn't sure if we did with the whole distance learning. I remember giving you guys a ton of time off. But they did remember some of it, but not the whole process, because we just touched on it. So we're going to assume you didn't learn it. Is that all right? Like if I asked you to do something by parts, you guys in here, do you think you'd be able to do it? Okay. And they're going, no. We checked out after the AP test and just did stuff to get it done. I get it. And I also said if you don't remember, when I taught it, I said it was primarily for the seniors moving on, because this would have been one of the first things they learned at college, and I wanted them to have heads up. But I knew I was going to do it again with you anyway. So this guy right here, if I were to say, hey, Catherine, integrate that, she'd look at it and go, well, I'll try U sub because nothing else is happening, right? And she'll say, well, if U is x, du is 1. That doesn't help me get the cosine. If U is cosine x, du is negative sine. That doesn't help me get the other one, right? So we're stuck. Unless you know by parts. By parts is used 95% of the time. And write this over here because we will do a couple examples where it's not the case, but almost all the time when we have what we call integrand is a product, so it has, and its derivation actually comes from the product rule. So the integrand is a product of, looking for my, never find it. I hate talking in this thing. What I call incompatible functions. Now that's my terminology. Like if you Google integration by parts, it won't say anything about incompatible functions, but that's what I'm going to call a trigger. That's where when you see it, you're going to be like, oh, maybe this is by parts. Maybe not, but it's a big trigger. By incompatible, I mean different function families. Like e to the x paired with sine x. One's trig and one's exponential. Those are not the same type of functions. Or if you see a polynomial paired with natural log, where their derivatives don't even resemble each other. Does that make sense? Or maybe we see tan inverse, and I'm not going to write arctan because I don't have enough room on this side, and maybe it's paired with x cubed, right? They're not compatible families, and they're always a product. So up here, I have a function that's linear and a trigonometric function. In other words, down here, I've got different function families. We're going to do that on the next page, but I like to show you where it comes from. You might not understand this, but that's okay. Okay, so we're going to do it really quick. If we do the derivative of a product and use the product rule, we go first, d second plus second d first. That looks familiar, right? And if we integrate the derivative, a uv pops up. Because they're inverse. It's like squaring a square root. They're inverses, right? On this side, we get u dv plus the integral of v du. But on the first one, it was a derivative, and I was taking the integral. Okay? What we're going to write is this. This is the guy that I'm going to solve for. U and the derivative of some function, so dv, equal to, and then I'm going to say uv minus v du. You'll never have to do that, and it's not really a formal proof, but it's coming from the product rule, and it's used for when you see a product in the integrand. Now, this can be hard to remember. So, because we're from Minnesota, I usually tell kids to think of this as oofda, but it's oofda. You see it? UV minus uv minus v du. It kind of looks like ooh, and it helps you remember it. Okay. And we're gonna have we're gonna lay it out in an array that'll help with that too. So down here, this is if you Googled by parts, this is what it would say. All right, I just give you a model. So how do we apply it? Let's go to the next page. You guys are so focused on how just your eyes like burrow into my brain. Look, because all I see is eyes, and they're like, never notice how focused you guys are. Like there's no sleepy eyes. Like Ditter's like, he's focused. All right, so back to this original one. We do not know what this is yet, right? But we know it equals something whose derivative is this. That's all I know. But what we're going to do here is decide one of these in here is u and one is dv. They're not always in the correct order. So what I'm saying is x is either the derivative of something or the cosine's the u. That's what I don't know. All right. So it says, how do you decide which is which? I'm going to give you a little helper, and I'm going to say be very careful with it. Okay? I use the phrase liate, or you might want to call it liate, but I like liate. It sounds better. It's tastier, right? So the L stands for the natural log for us, because we don't do any other base. So if you see ln x paired with anything, it's the u. Okay? I'll tell you why it gets to be the u first once we're done. Okay? Inverse trig is next. So if you see any arctan, arcsine, etc. I suppose I should put that. I should put the argument in there, otherwise it's not good. Algebraic is what the A stands for. Those are your polynomials, like x squared or like that x that's up in the x cosine x. That's going to be classified as the A. Be careful because x to the 0 is also considered algebraic. Did you see what I just put up there while you were x to the 0 or 1 is considered algebraic, or any combination. So all of this minus 7. That's what I mean by algebraic. They look like polynomials. Watch out for 1. Okay? The next one is trig. That's your sine, cosine, tangent, all that good stuff. All right? And lastly, exponential functions, in particular e to the x. I doubt you'll have much of like 4 to the x or 5 to the x. It's really not about selecting the u. The u choice comes from, I'm going to go down here. I'm going to show you where it actually comes from. So when College Board tries to test that you actually understand the process, they might ask it differently. But take a look. This would be classified as algebraic. What would this one be classified as? Trig. Okay? So my u choice is determined almost always by this phrase. So my algebraic beats out the trig. So you're going to write this, u equals x. And then you're going to add a cross on a 2x2 array, and you're going to write dv equals the rest of it. How are we doing so far? I know this is going to equal uv duh. uv minus the integral of v du. So I've got the u. I don't have the v. I also don't have the du. But we can do it. What's the derivative of x? 1. So du dx is 1 dx. So that's going to be going in for du. To undo a derivative, what do we do? Integrate. I just love this process. Actually, if you were to ask kids who had Calc 2 last year, what did you like to do? A lot of them are like, I kind of like the by parts. There's some other stuff too, but whenever we'd review and they're like, yay, it's by parts. I'm like, you guys are weird. All right. What's the antiderivative of cosine? Sine. Okay. So here's all my working parts for integration by parts. You get its name, right? It's integration using 4 parts. Now, if you lay it out in this array, you can just go multiply, minus, integrate. All right, you can just zigzag. You won't use the dv, and the dv isn't over here, right? So you can just go u v minus the integral of v 1 dx. Now do you see that it's broken up into parts? you know how to integrate that part. What's the antiderivative of sine? Negative cosine. Excellent, you guys. So this would be plus cosine x. Don't forget you're integrating. So we also have Carl. How was that? Now, how could you test it? It says check it. Derivate it. Yeah, let's take the derivative. Product rule. First d second. Again, I should have written y equals or whatever, but first d second plus second d first. And the derivative of cosine is negative sine. And the derivative of any constant is 0. Gone, gone. What did I get when I took the derivative? The integrated, right? So I must have the correct antiderivative. Now I want to talk to you about that u choice. It's really not about who's u. It's about who's easiest to find the antiderivative of. Really, the by parts kicker, and a lot of people don't teach it with that Liate model. They'll say, what's easier to integrate? But sometimes that's up to personal opinion, because Annie might think x squared over 2 is pretty easy, but Katie might be going, well, that's just sine x. So which is easier? I think that's a little too subjective to the person doing it. Does that make sense? But it really is about which one's easier. Because if I go to this, arctan, and I pair it with e to the x, which one's undoubtedly easier to integrate? E to the x, right? So do you see why that's my last u choice, right? Because I want it to be dv. Because what's the antiderivative of e to the x? E to the x, correct? Do you see how the first choice is the natural log function? Until today, if I asked Witter, hey, kiddo, what's the antiderivative of natural log? She'd be going, is there one? I don't think we learned that, right? Did we ever learn that? We know its derivative is 1 over x, but we never took a derivative and got natural log, right, Annie? We will today, okay? But that's why that gets first u choice, because to integrate this, I have to do by parts. So that's circular reasoning. I don't know if you get what I'm saying. So let's go practice up here. Is this your next one? Sometimes I switch the notes up. Yeah, awesome. So I'm going to use this both with a definite integral over here and an indefinite integral on the left, and just show you how it doesn't really. So if I go up here and I say u sub, u is usually the exponent. Its derivative is 1, not x. But watch me tweak it, guys. If this is on your test, now you run the risk of going, oh, incompatible functions by parts. But who's always your go-to? U sub. You always try it in your head first, and 7 out of 10 times it's the winner. This chapter's about when it's not, but do you think I'm just going to still throw some of this at you? Yeah, because that's the most important technique there is, okay? But right here, U sub fails, so then I wanted her to go, oh, by parts, right? All she has to remember is who is U, who is dv, okay? So she's got 2 fighting function families, algebra, fighting, exponential. Who gets to be U? The x. And it's not really because that's x, it's because e to the x is so easy to integrate. What's the antiderivative of e to the x? E to the x. But Annie might think x is pretty easy to integrate too. So do you see why I don't like that? I kind of want you using this model. So my du is just 1 dx. So then I just say that the integral from x, e to the x dx, is equal to uv minus v du. Moved it. How are you doing, Daniel? All right. So Daniel, what's the antiderivative of e to the x? Okay. So this is just x e to the x minus e to the x plus my good friend Carl. Maybe an e to the x gets factored out on multiple choice. Now, if it's a definite integral, you can wait till the end, but understand that this piece is also going from 0 to 1. So once you do the UV, you have to realize you have to do that from 0 to 1 as well. Does that make sense? So, or you can wait till the end and do the whole, by the way, you should have told me. Carl's out of there. Why is Carl out? Yeah, I wasn't paying attention. Well, now I'm going back to do the definite, so now I'm paying attention. But anyway, so now you need to plug the 1 and the 0 in here and in here. Does that make sense? So we would do 1 e to the first minus 0 e to the x. And then on this one as well. So I'm not going to finish that off because you guys know how to antiderivate. Now I'm going to have you guys try one on your own. This is definitely a by parts, like in your face. Yes. Yep, you can do it like that. Yeah. No. Actually, I like that better, so. I just said you could factor it out, and I didn't. So I challenge you to do this one. It will have Carl, because it's not a definite integral. This is like a very typical multiple choice. Does the kid know how to do by parts? And it's just in your face. Bodie, do you know what I mean by in your face? Like it's obviously not anything else. It's two definitively incompatible functions. Go ahead and try it. Don't look up here till you're done. How are we doing? Good? Do you see how once I have it broken up into its by parts, the part left to integrate is always quite simple on this level. We're on level 1 today. Do you think they'll get harder? Say yes. Yeah. Significantly so, but the pattern won't change. So that's what's nice. All right, so when I'm done, it looks like I have x cubed thirds ln x. By the way, why was my u choice ln x? There's two things you can tell me. Why is the u choice ln? Because it's the L, right? But it's really not about that. It's because if you chose to have it be the dv, you're stuck. And the only way you can figure out what, and this is our next example, the antiderivative of the natural log function is to use by parts. So it doesn't make sense, right? So watch what College Board, can I quit? Well, this would be 1/3 x cubed over 3, right? And then plus Carl. And then maybe there's a x cubed thirds factored out. Just, you know, if it's FRQ, leave it. If it's multiple choice and you need to match it with something, factor it. Now watch. I'm going to show you what College Board sometimes does. And it was on last year's BC test because remember for you guys, it was all sort of like tabular and graphical. Like you really didn't know your functions. They're like K and W. And, you know, if you were doing the quotient rule, it wasn't with sine x over x cubed because anyone at home could just go Google that. You could snap it, you could put it through Wolfram, right? But when same with by parts, if they were tested on by parts last year with e to the x sine x, that's a quick Google. That's a quick Wolfram. And College Board was brilliant with the creation of that test. It was tabular. And so luckily I had stressed with the kids that it's not about Liate, right? It's about who's easier to find the antiderivative of, right? So of these two, who's easier to find the antiderivative of or to integrate? F prime. So that was their dv choice. And they didn't even know what f was. They don't know if the derivative of f was exponential. They had no clue. But they did know that its antiderivative is simply f. Do you see what I'm talking about? So yes, Liate is awesome, but understand it's really not about u. It's about dv. So I'm going to go back up here, which means u would be the g of x. What's du then, symbolically? G prime. And it was a definite integral. Let's say from 3 to 5. So they would have to say g of x, right, times f of x, minus the integral of g prime, f of x, right? And they'd have to read stuff off a table. Does that make sense? So be very careful with memorizing Liate, but I think, is this my last one? Does it say something about a 1 through 10 on the bottom here? Yes. Last one before you go to the worksheet. It only is 1 through 10 though. We're just touching on the beginnings. So, oh, there's 2 on here. I guess there's 2 more. This guy, we've never had before. You can't integrate it without by parts. And then you might say, but there's only one function in there. There's another one. 1. Now be careful. Who's your U choice? Who's your U choice? Yeah. Do you see how silly it'd be to put that as dv? You'd need to integrate it in order to integrate it. Now you're nodding. When I said circular reasoning, no one nodded. Like they didn't think you knew what I was talking about, but I knew I was getting here. Letting dv be the natural log is silly. All right. So my u is ln x because I know its derivative is 1 over x dx. Next step, my dv is 1 dx. What's its antiderivative? Don't say 0. What's its antiderivative? X. This might be one you want to commit to memory now because it does pop up quite a bit. You don't want to have to keep by partsing it all the time. This is now going to become kind of like the antiderivative of secant squared is tangent. Like you don't want to derive it every time. So let's go uv x ln x minus the integral of v du. 1. Boy, that fell apart nicely, correct? What's the antiderivative of 1? X. X ln x minus x is the antiderivative of the natural log function. Do you trust me, Annie? Say no. Well, Annie, I know how to take derivatives, so let's go check it. Product rule, first, d second, plus second, d first, right? Derivative of x is 1, constant is 0. Did it work? Cool. Math is awesome, right? Now, we haven't done the antiderivative ever of the inverse trig functions because you couldn't. This could never have been an AB because in order to find the antiderivative arctan, I know the antiderivative of 1 over 1 plus x squared is arctan x, but I don't know what the antiderivative of arctan, the derivative of what is arctan. That's never happened, right? So this is by parts. Who's the missing function? Now, College Board will never do that because they don't want Mason to get it wrong because he just doesn't see a 1 in there, but he knows by parts. So on the AP test, they're in your face, or they're sort of in your face. How about that? Which one do you know the antiderivative of? H double prime is your dv. What's its antiderivative? H prime. Okay? So they might do that to you, but they won't pair it with a 1 because they don't want you to not get credit because you just forget that. So let's go through our U choice. Who U? It'd be silly to let it be arctan. Agreed? Because, it's silly to let dv be arctan because I'd have to integrate it. So again, circular reasoning. So U gets to be arctan, dv gets to be 1, dx. Now, do you remember what the derivative of arctan is? What is it? Pretty ugly What's the derivative of arctan? 1 over, perfect. Yeah, 1 over 1 plus x squared, thank you. I know it's derivative, that's why it's my U choice. I don't know its antiderivative yet. Okay, what's the antiderivative of 1? So again, you couldn't memorize the UVDA, but if you set it up in this array, you can just head across like that. UV, so x arctan x minus, now we're moving into a medium one, the integral of x v du. Now it's not quite as obvious, right? Be careful with this. This could have been on a test last year. What would I have been checking off my box? Student knows how to integrate using U sub. See, now they're mixing, like, wait till we get 3 more. Like, you really have to have your poop in a group with all the techniques. Who's you? 1, yeah, 1 plus the x squared. Now, again, if you do it in your head, that's fine. Just don't be sloppy. So your du is 2x dx. Dang! Better correct it, because I just want x dx left. All right? How many of you do that in your head now? What do you think I'm going to say? Be careful that you don't forget the fraction correction. But it's expected, so there aren't points for showing that. That would be considered Calc 1. They'll be tested Calc 2. So you can do that in your head now. But it'd be x arctan x minus the integral of 1/2. And then using the denominator, the rest of it is du. This one checks off a lot of boxes. Student knows U sub, student knows by parts, student knows the derivative of arctan, student knows natural log. Excellent. Students do know. I love you guys. It's kind of fun learning something new though, isn't it, Mace? Like when we've been doing so much review. Natural log, be careful. Natural log of what? This one, it should be absolute value, but if Yoder either purposefully did parentheses or not, it wouldn't mark this one wrong. Someone just nodded. Why on this one don't you actually need the absolute value bars? My OCD just kicked in. Did you see me do that? That was totally bugging me. Anyway, if you didn't see it, it's weird. Okay, anyway. My question was, why do I not need them? Yes, and if that's the case, you can drop them, but I would just always have them there. If that was x squared minus 1, I have to have them. So you might as well just always put them in. All right, what do you think of integration by parts, level 1, day 1? Okay. Integration by parts, level 2, day 2, comes Monday after break. Your assignment. I'm trying to think of where I have the PC. Worksheet number 3, 1 through 10. 1 through what? 10. Merry Christmas to you. And I will have you submit 1 through 10, but then don't throw the worksheet away because we will finish the rest up. All right. Those of you at home, I believe I linked this. They are working the last 20 minutes here on 25 minutes, 1 through 10 on worksheet 3. And I'm going to wait until somebody gets an answer to the first one, and I'll put it up before I turn off the video. So you can fast forward to when I give an answer. Again, Liate is awesome 95% of the time. But understand it's really not about you, it's about DV. I'm just going to go walk around and see if I have an answer match, and I'll steal it. I don't feel like doing it myself. It's fun learning something, right, Herb? Let me see if yours matches Bodie's. If it does, can I steal it? Unless you both did the same mistake. All right, so number 1, negative x cosine x plus sine x plus c Do you guys agree with those two chumps? Yep. All right. I'm going to stop the video there. If you didn't get that, though, raise your hand, and I will fix your by parts.